This is Khashgar, and with part 6 of Snake game with Python and Turtle. So in last part we fixed the contact method, which is the collision between snake and apple, and here in the update method we print something that shows like we have contact, or we had contact. Now let's change it because we want Apple to change its position and go to the new place, and in the same time we want our snake get bigger. So let's clean up this, and here right, okay, no, until here. If self this contact snake, okay, let's clean up the pass, and we write another method here, define, we call it jump, because we want our apple to jump to new position. So we have to have its coordinates, and how also here I'm going to fix the minor problem. I don't know if you notice it or not. Let me show you what was the problem. Alright, you see here when snake is colliding to apple, it's a little bit not in complete coordinate with snake. It's a little bit up, down, left or right. So how we can exactly fix it so every time we come exactly to the same coordinate and same block? I mean, for example, when we want to send the apple to a new location, that location, it should be somewhere exactly aligned with our snake object. Alright, first we need to have some variables here. X for x coordinate, for example, x equal random dot range between minus 245 and 245, and y for ycore, or y for ycore, then it will be random again, same code. Then let me just copy here and paste it here. So basically every time we collide, then it will jump to another position. Then here we can write where it was our I almost forgot what I want to do. Oh, I want to write that collision. Okay, then if self dot is contact, if self dot is contact snake, then self dot jump, let's see if it's working. Okay, come here. It's not jumping because we didn't even call it. We have update method here, apple update, then yeah, we just create some variables, we didn't go to it. Then we have to also go to those variable, the places. So then where is it? Today I'm a little bit foggy, so update, here. Then self Okay, see, it's jumping to new position, and we can have a score. We can increase the length of the snake. And okay, now let me to fix that minor problem. We have to round it by the block size what we choose for our snake, and the block size was here. The steps was 12. We can take it as our block size here, and how we can round it exactly to that block size. We get our variable by random number, so this x will be something, a number, whatever it is. We say x equal 12, which is our block size, multiply round, again x divided by block size. This should take care of it. And also same goes for y coordinates. So we just copy here and we copy here, we paste it here, change the x to y. Now we have round positional number. Save it, go one more time. Invalid y by 1, invalid yes, should be one more parentheses. We add here. Oh no, should be something else. Okay, it's walking crowd actually exactly aligned with our snake. Okay, this is enough good for this game. Then what's next? Okay, okay, it just dawned on me, like let's say our next jump is exactly on the snake location. It's very less likely, but we need to consider that possibilities. So we need to here write very short if statement by here. Before we say self go to those coordinates, we say if x and y in snake dot body anywhere, because eventually the snake will grow and will take more space on the board, so it is somehow possible, like our apple jump to the same location that our snake body is occupying in that moment. So if x and y in a snake dot body, then we simply call the jump method one more time. Self.jump. And else, if not, then just go to new location. And these should take care of where is it? This object's not callable. What this was for us, snake body. Oh, I made a mistake again. Shouldn't have parentheses there. Okay, and we can be sure that apple never jump to same place as our snake occupied in the same time. And also let's increase the length of the snake now, if we haven't done it here, so we can just write it exactly in Apple update method. Self.jump snake.tail plus equal 1. If it was a snake tail, all right, the snake.tail plus equal 1. This should take care of the length of the snake. So let's see it jumping and the snake grows. Alright, cool enough. Now we need to take care of two major things, which is first, if we go out of the board, something like that, we should lose and the game should be over. Or when we are when we have a long snake, we can't go backward because the snake will collide by itself to its own body, and that should be also game over. So let's try to do those things. The first part is really easy because we simply can add something in snake update. Actually, in first time I could write this game, I wrote it this line in my main game loop, and what's the link which I had already in GitHub is also this line is in main loop, but I think it's possible also to do it here, so we can write it if self.xcore greater than 264, which exactly it's the edge of our border, or snake.xcore less than minus 264, or this actually should be self, or self.whitecore greater than 264. Now it's a little bit long code, or self.whitecore smaller than minus 264. Then we can write just exit. Let's see if we can jump out of the program. Okay, left, right. Of course, after we can write game over and wait a little bit, and display the game over script on the board. And so this is good. This is all good. Okay, so I try to actually I told this before in the last video, but I think it's long video. How long is it until now? Maybe 15 minutes, I'm not sure. So let's do it in next video. Thank you for watching and see you in next video.